Hello, good morning, guys. So I felt like I should make this quick video before I, I had to work. Now, in a couple of my videos, I've talked about um, matter and the three states of matter, liquid, which are liquid, gas, and solid. And all these gases, they behave. All these state of matter, they behave in a very unique way. So this morning, I'm quickly going to go over how gas behave, and some of the scientists that have studied behaviors of matter. So today we're going to be talking about Boyles. So if you guys have not heard about this before, Boyle's law. So Boyles, he was a scientist from Ireland. So he's an Englishman. So he studied one of the behaviors of gases. So he compared two entities, so which are pressure and volume at constant temperature. So Boyle said that when you increase the pressure of a gas, then the volume will go down. So that is just a simple definition. So when pressure goes up, then volume goes down. So they have an opposite relationship, and in science we call that an inverse relationship. So when you increase the pressure, the volume must go down, or vice versa. When you increase the volume, the pressure must go down. Or other way, when you decrease the pressure, the volume must go up. Or when you decrease the volume, the pressure must go up. So they work in opposite directions. So an example is, so let's say you have a balloon filled with air. Now, so if you try to compress the balloon, so that means you're increasing the pressure inside the balloon. You're increasing the pressure. So the gases inside the balloon will be compacted together. And so what happens when you increase the pressure, you see that the volume will go down. Because you see, so this is the balloon. You increase the pressure, you're compacting it. So that means the pressure is getting very big inside the balloon. So what's happened to the volume? The volume is going to grow. Because why? Because the balloon is going to shrink. So there's a lot of pressure inside the balloon, but the volume shrinks. So the volume of the balloon is going to shrink. So that is what Boyle's law says. And there is a little calculation involved in this. And I'm going to show you guys quickly how to do the calculation. So I want you guys to keep on watching this video to the end, so that you guys will see how simple it is to do a Boyle's law calculation. And we have several scientists as well that talked about the temperature, the volume, the pressure, the moles, and all that. And we're going to get into that in a subsequent video. But for today, it's all about Boyle's law. So it's all about you understanding gaseous behaviors. All right. So let me give you an example. So let's say we have a balloon. So the balloon has, let's say, the volume is 2 liters, and the pressure is, let's say, 4. So 4 Pascal. Now, so this balloon, the volume was reduced. So let's say we have another, the volume was reduced to 1 liter. Or let's say the pressure was increased to like 8 Pascal. So what's going to be the volume of this balloon? So the first volume, V1, the first pressure is what? P1. So pressure 1 first, volume 1, pressure 1. Then this is our second volume, the second pressure rather, so P2. Then we are asked to find what is our V2. So are you guys following me? So this is the formula we use. So we always say P1, V1 is equals to P2, V2. So pressure 1, volume 1 is equals to pressure 2, volume 2. So how do you now find volume 2? So we do a little bit of manipulation here. I've done this so long, so I would know immediately what to do. So in my own case, what I will just do is that I will bring my pressure to under V1 P1. So you see, so I've isolated what? I've isolated my P2, my V1. So you guys can now see that to calculate my V2 is just going to be P1 V1 divided by P2 divided by P2. So that's going to be how to find this, but in a more simpler way. So let's say P1 V1 is equals to P2 V2. So we want to isolate our V2. So what do? We divide this whole thing by P2. So let's say, look at it. So divide by P2, you divide both sides by P2. So the P2 divided by P2. So we cancel our P2 and C. So we've isolated our V2. So we have P1 V1 divided by P2 is equals to what? Our V2. So you guys could see that it's still the same thing. See, it's still the same. P1 V1 divided by P2 is equals to V2. P1 V1 divided by P2 is equals to P2. V2 rather. So now all we need to do is just to plug in our numbers, then we'll get our V. So let's use this. So what's our V1 here? Our V1 is what? 2. What? Sorry. So what's our P1? P1 is what? 4. What's our V1 here? So V1 is what? 2. Then we divide by what's our P2? Our P2 is what? 8. So let's cancel out. So this is going to be 8 divided by 8 is what? 1. So our V2 is going to be what? So V2 is going to be what? 1. 1 what? Liters. And it makes sense. Why? Because we increase the pressure. So what do I say about when you increase the pressure? They have inverse relationship. So if you increase the pressure, the volume must go down. So it makes sense, right? So the volume went from, the pressure went from 4 Pascal to 8 Pascal. So what's going to happen to the V2 here? It must go down. And that's why we got 1 liter. So remember, Boyle's law says that pressure has an inverse relationship with volume. So I hope that you guys are enjoying this, and I hope that you guys are learning a lot. So if you guys are still watching this, so that means you guys are interested in getting something. So this is just going to be the time to smash that like button, subscribe, and turn the notification bell on so that you guys will know when we get notified when I post next video. So this is what I have for you guys this morning before I head to work. So I hope that is very clear. So once again, it's a growing channel. Please like, subscribe, and share the video. Thank you guys. I'll see you guys next time. Bye.